Welcome to today's lecture, where we're going to talk about some of the assumptions that we make when we use continuous variables in our statistical testing models. Now, continuous variables, you remember, are those variables that are numerical and that fit on a particular spectrum. So the values can go on a spectrum with the lower values or lower variables down here and variables of higher quantity or number here. And this distance accurately represents how far off the two variables are from one another. And the most common continuous variable we see is age. Now, there are two ways of performing statistical analyses on continuous variables, and that's what we're going to talk about today. One is called parametric, and we'll go into more details about this later on. And of course, the other is non-parametric. And the way to tell which type of statistical tool you're going to use will depend on whether the variables, the continuous variables, fall under the parametric or non-parametric categories. So let's figure that out. Let's talk about that. There are certain assumptions that one makes when you or I are working with continuous variables. And we're going to go through three common assumptions, and then we're going to talk about what these assumptions mean. So we've got three, and the first is called normalcy. Also known as a normal distribution. The second one is called independence. And the third one is called homogeneity. Now, if these three are met, which means that the data you're working with as a normal distribution is independent and has homogeneity, then you can use parametric testing. If, however, the data doesn't meet one of these criteria, then you've got non-parametric testing. So let's talk about what each of these mean. And then we'll go through what type of tests can be done with parametric testing and non-parametric testing. So the first assumption that we make is normalcy. And really this refers to having a normal distribution of your data, also known as a Gaussian distribution. An assumption is made here that the data that you collect will be distributed in what's called the bell-shaped curve or the normal curve, where what you're measuring here, or your x-axis, is your variable. In this case, we'll use age. And the y-axis here is the frequency, the number of people who fall within a certain age. And most of the people fall here, in this age range. And then there's a good number of people that fall here and here and here, and a relative equal frequency that fall down here, till you get to the extremes of age where there are very few people on either end. This is the normal distribution. Not all data will fall within the normal distribution schema. You can have skewed distribution, such as this, or this, where most of the people don't fall within the middle. There you go. So these two here, B and C, represent non-normal distributions, whereas A represents the normal distribution. And this is important because, of course, if you don't have a normal distribution, you're not going to be able to use parametric testing, which we'll discuss in a later lesson. You'll have to use non-parametric testing. Now, we'll go a little further and figure out how to determine if some data is normally distributed or not. And the best way to do that is to look at what previous scientists have discovered. And this is one of the reasons why there are pilot studies. If you're performing a study on a set of data and you're just not sure if it's normally distributed or not, you can use your pilot data and come up with a graph that tells you how your data plots. And if your data falls within a range that appears like this, a normal distribution, then you know that doing a larger study will allow you to use parametric testing. You could also ask your statistician, who can do some fancy testing of the data that you provide him or her to determine if the distribution appears to be normal or not. So that's the normal distribution. If you have it, it's a good way to use parametric testing. If you don't have it, not to worry, you can do non-parametric testing. Thankfully, most of the data that we use in medicine, or the data that we collect in medicine, is normally distributed. But if you're not sure, you can either run a pilot study and see how the graph looks, or look at some of the data from the historical literature to see if the distribution is normal or not. So the next assumption that we make is independence. And simply speaking, if you're testing two groups of people, Group A and Group B, and say you've got an intervention that we'll label here as I intervention on Group B, you want to be sure that Group A has no effect on Group B. So the two groups have to be independent of one another. If they're independent of one another, then you know that you can use some parametric testing. So that's easy to do in most cases because you can just choose a set of patients for A and a totally different set of patients for B, and therefore they will have very limited relation or influence on one another. And the third is going to be homogeneity. So your data has to be homogeneous. It doesn't have to be the same, but it has to be of similar type and respond to the intervention in the same magnitude. So say you have A, group of patients labeled as A, and B. And you have an intervention, I, which is going to act on B. Well, if I acts on B, you can hypothesize that something will happen to B that doesn't happen to A. So say what happens is that B advances forward. So all the patients in Group B have advanced forward compared to Group A. They've stayed in the same place. But you want homogeneity in the sense that the intervention has a similar effect on all of the patients and not wide-ranging effects. So it's not that only some of the people in Group B move this far and some of the other people in Group B just move this far, which we can label as B prime. So we want to see some sort of a similar effect, a homogeneous effect on all of the people in Group B. It doesn't mean that they all will benefit in the same way by having this intervention, because some of them may have started off in worse shape than others in this group, but that they all get a similar magnitude of benefit. So if you have these three assumptions met, normalcy, independence, and homogeneity, you can then use parametric testing. And of course, if you don't have any of these, then you're going down the non-parametric route. And that's it for today's lesson. Thank you very much.